Okay, so on this first problem, it asks to say how many different four-letter words can be created using the letters from MATHROCKS, no more than one. So you're picking four of those letters, and you can only use them once each. So you have to have four different letters. That's what the no more than once means. And so in this case, because it's a word, this is a permutation problem, because an order matters when you're talking about words. Right? There is a certain order to every word, and so an order does matter. So this is a permutation problem, and there are 9 letters in Math Rocks. And so you've got 9 letters to choose from, and we're going to rearrange 4 and see how many different ways we can rearrange 4 of them, of those 9. So we're going to do 9 permute 4, which just equals 9 times 8 times 7 times 6. Remember, this is the number you start at. This is how many numbers you multiply together. So we multiply 9 times 8 times 7 times 6, and we get 3,024. So there are 3,024 different words that can be created using the letters Math Rocks. 12 says, phone numbers in Sickaville are 8 digits long. So you've got these 8-digit numbers. If the first digit can't be 0, so that means there are 9 possibilities for the first digit, but the other 7 digits can be any digit. How many numbers are possible? Well, because it doesn't specify that each digit has to be different. This is a counting principle problem, right? A multiplication principle. And so what you're going to do is, for each spot in the phone number, right? There are 8 of them. We've got to think about how many numbers can we use. Well, for the first, because it can't be 0, there's only 9 choices. But then after that, there are 10 for each of these, 0 through 9. And it didn't say that things can't be repeated, so you can assume that it's possible to repeat any number. And so there are 10 no matter what. Each space in the number isn't dependent on the number after that. So you multiply this together. It's going to be 9. You've got 10, so that means 7 zeros. And so you're going to end up with a total of 90 million numbers that are possible for Sickaville to use. So there are 90 million numbers for Sickaville to use.